Okay, awesome. So, hey everyone, welcome back to Django week. Today, as you all know, is week day two of the Django curriculum. If you guys want to open up the README for this morning, that's basically what we're going to be following in lecture all the way through. So I'd highly encourage you guys to do that on your own as well while coding along. So to start things off, let me go ahead and share my screen real quick. And we'll talk a little bit about validators and testing before getting into how we actually do it. So yesterday, you guys talked about how to create models and connect them to your databases. So the four steps that were the three steps that we had previously for creating a model were creating your model in Django, then also creating your database, hooking it up to your database and the settings, and then using your make migrations and migrate to basically, you can think of it like pushing your model changes from Python code into your SQL database. Well, today we're going to add in two more steps to this. The first one is validating fields, which I'll get into on the next slide. And the next one is testing your model. So remember, models in Django are literally Python classes, just changed a little bit and Djangoified so that we can use them in SQL. So the process that we follow when creating a Django model should look really, really similar to that of creating and using a normal Python class. So just like creating a model, we can create a Python class. We don't really have a migrations thing in Python, so we can forget about that. But we have to test our classes. But also, we need to incorporate edge cases into our classes and our functions as well. So that is where validators come in handy. So as it says here, we need to ask ourselves a few questions while creating or before creating our model. So we need to figure out, what are we going to put in our model? How am I going to represent my model in my database? And the last point on here is critical for us today, which is what fields does this model need to work the way I intend it to? And that is where validators come in handy. So validators basically give us a way to error check each of our fields. So it lets us specify things like format, length, acceptable values, even data types, stuff like that, just making sure, hey, when I type stuff into this field, is the stuff I'm typing in what should be typed into this field or not? So if you think about it, like if you go to a website and they have like a sign up button and you need to put in like an email and a password. And in the email box, it says, okay, you need to type an ampersand, you need to type an @ sign, and you need to say like .com or .net or something like that. Or for the password field, it could say, okay, you need to have a password that's between like 8 and 20 characters long, and it needs to have one special character and 3 capital letters and stuff like that. All of those things that basically check what you're putting into that field and thus check what you're putting into your database are known as validators in Django. Are there any questions about what validators are before we start talking about how to use them?
Seems pretty straightforward.
Should be, but let's see. So student questions. Okay, we can talk about the migration stuff after a little bit. So let's jump into, oh no, where did VS Code go? Not that, not that. There we go. All right, so hopefully you guys can all see my VS Code now. If not, please let me know. For basically the rest of the week, we're going to continue playing with our Pokemon Pokedex project. So we're basically going to be using this for the next 2 days. So if you guys want to open yours up and code along, and make sure to enter your virtual environment like I have down here, that'll greatly help accelerate things along. Okay, so just to recap some of the stuff that you guys did yesterday, right? You created your Pokedex project, you created an app within that. We went into settings and added the Pokemon app to our installed apps. We created some models, about one model really for our Pokemon, which has all of these lovely fields. We've created some string methods, like the Dunder method. We created some that change the levels of our Pokemon. And we also have a database. So I can check what's in my database, which is PSQL and then Pokedex VB. I've entered into it and I can go, let's say, select, see if I have that. Yeah, select star from, and then the Pokemon app is the name of the table. And then we want to check the name of the app. And then to get the name of the table, we put an underscore and then the name of our class, which is Pokemon. And we see that I now have 2 Pokemons in there. I've got Pikachu as one of them, which is level 12 and is captured, not captured yet. We have the date captured and the date encountered. And we have a description that has a typo. It should be unknown with an N, but that's fine. And then we have Charizard, which has other characteristics as well. So let's see. There we go. Oh, that's why it's covered by the screen sharing button. Okay, that explains why I couldn't see. All right, let's move that there. Perfect. Okay, so we can quit out of the database real quick. So hopefully all of you guys are at this stage now.
Just
So
to
there's
clarify,
oh, good.
so we were doing the school database and we were doing the other one, the Django ORM assignments, but we didn't actually, like, were we supposed to actually create a Pokemon app as well?
So that wasn't an assignment, but that was just the stuff from the README from
Oh, okay.
yesterday.
So
So
just like the
yeah,
curriculum portion. Okay.
basically. So we're gonna basically keep building off of like the days before's README, like every single day. So if you want to code along with the README to help follow lecture, that's something I highly recommend, but it's not like required to do this or submit it or anything like that.
Okay, thanks.
And yes, Jesse, yeah, the matching code is on the README if you just want to blaze through it a little faster too.
To get the time zone, don't we have to go into the shell, right? To be able to use timezone.now?
Nope, you can do it in here as well. So if what you're referring to even is, you'll get an error if you run it with timezone.now and the parentheses. And from what I recall, that is something that needs to be run in the shell. But if you remove the parentheses and you just run default equals timezone.now, which is like a variable, it's not running it as a function, or it's not running it as a function that needs to be run in the shell, then you don't need to do it in the shell, if that makes sense.
Okay, yeah, I was just asking because mine I didn't have that field yesterday, but now that I added it, it's saying time zone is undefined, so I just didn't know.
Oh, you might need to import it up here.
Oh, yep.
So yeah,
Thank you.
it's from Django.utils and import time zone. Hopefully that should fix it.
Will it work the same?
What do you mean, Roger?
The time zone that now would it work the same it did in the shell?
It should.
Huh.
But yeah, if it doesn't, then that's a little bit concerning. And yeah, like Francisco said in the chat, the shell is basically just creating like a temporary Python script of sorts. So when you're running in the shell too, you need to make sure that you import your time zone. But we won't be using the shell too much today. It'll be more dealing with our models directly. Any other questions about where we're at right now before we start putting validators in here?
With the way the code is now, for date captured, it would do like a time as soon as it was created, right? But we wouldn't want it to do that if captured was false, right?
Think so. That sounds correct. So if we go up to the table here, right now our date captured just puts in basically the date of creation of your Pokemon in there. So like for example, I created my table, or I created my Pikachu yesterday at 12:50 local time. So it puts that in as the captured. Now here it leaves it as even though captured is false, it still shows a date captured. That is something that you can change. We won't go into how to do that today though, but there is a way to basically check, hey, if my if it hasn't been captured, then just leave date captured as blank. If is captured is true, then change date captured to timezone.now. Yeah, so Nicholas, okay, Francis answered your question. And yeah, so Christopher, this will be in the day 2, part 1 README. So, and there'll be the intro validators and tests. All right, any other questions I can answer before we get into the new stuff for today? Okay, cool. If there are, again, feel free to let me know. I'm happy to stop and pause for a little bit. All right, so we have a lot of different validators that we can use. These should be listed in, I'm pretty sure that there's a link to them in the curriculum for today, but let me just send it in the chat. Yeah, here, I'll send it in the Zoom chat. So there's a long list of validators that Django gives us by default. So there's like a regex validator. If you have an email field, there's stuff for URLs. There's like minimum and maximum values, how many characters you can put into a field, whether something should be a decimal, things for like null characters. Yeah, there's a lot of stuff we can do. But for today, we're not going to explore all of them, but we'll look into at least the most commonly used ones. So starting off with our name field, max length isn't exactly a validator, but it sort of acts like one. But it's not a validator on its own because, well, we're not calling it a validator. But there's the maximum number of characters you can put in a regular char field is 255. Here we're just saying that the maximum length of the name is 200. But let's say that I did want to put that in as a validator. So just like our models and time zone, we have to import our validator as well. So we're going to type from Django.core, which is where our validators live, or validator function. We need to import validators. But if we just import validators, every time we want to write a validator, we have to say validators dot. That's really long. Instead, I'm just going to import validators as v. That way, whenever I need a validator, I can literally just say v dot and then the name of the validator. So let's go to, all right, so name is pretty fine. Let's do level. So let's say that our Pokemon only should have levels that go from 1 to 100. So I'm gonna put my comma in here. Let's see, we have a bunch of different fields. We've got like a primary key, and it's not a primary key. Got like the maximum length, a database index. But what I'm looking for is this guy down here. So I want to insert validators into my model field. So we can do that using the format of the thing I just highlighted. So if I type validators equals, and let's see if I mouse, oh, that didn't work. Okay, let's try that again. Nope, okay, it doesn't want to do that. Well, when we put validators into our functions, we can't just put them in like by typing them out with spaces. Instead, we need to put them in an iterable of validators. An iterable, if you guys will recall from Python, is basically just a list. So create a list of all the validators that you're going to apply to your field, and then just put that list inside the validators equals field. So let's say for our levels that we want to say levels from 1 to 100. So we need to obviously create a minimum and a maximum. How can we do that? Well, lucky for us, there are literally min value and max value validators. So to access our list of validators, we can use the v dot. And then we see we have all of these. We have like a base validator, decimal, email. But what I'm looking for is min value validator. And if we mouse over this, does it tell us anything about what it is? Yeah, okay, so it says min value validator. We can put in a limit value, which I'm saying that the minimum limit is 1, and we don't need an error message for it. Similarly, we can also add in a max value validator, and that maximum value I'm going to specify is 100. And that's it. But that's really all we need to do for validators. So again, if we want to validate a field using a built-in Django validator, we need to go to django.core, import the validators. I'm choosing to import them as V. You don't have to do that, but if you don't do that, then you'll have to replace the V dot with validators dot and validators dot, which is long and does not look great. So keep doing it with import validators as V, is what I would recommend. Then in examples, we also always need to put them in an iterable or a list of validators on import, and validators are classes that we imported. So any questions about the generic validator import and use format before we go into a couple other examples?
So you mentioned for this, I don't know who just talked, but sorry, you mentioned for this specific example, we don't need an error message. How would you input one of those if we did need one?
Good question. For a validator error message, what we would probably need to do is, let's see, go in here. I think we should just be able to specify message equals error message using this. So we could, I think, just say this is an error. That should probably do it. So basically just inserting in an error message from what I recall.
Okay, cool, thanks.
Can
Any
you
other
do
questions?
can you do like a method and just put that in instead of just coding it out? Would that be possible to do?
So like
just have
making your own validator, basically?
Yeah, just have like a functions, just show an error message instead of just writing this whole line. I feel like it's kind of a little too long, but if I just have a function outside of this class and just call it if something is not right, would that be possible?
I guess, but I mean, you wouldn't really want to use a function to create a field necessarily. So, like, what we were basically doing here is just the whole line does look a little bit long, but if we break it down, we're basically doing 3 things. We're creating a field for level, that's an integer field. We're setting the default value, and then we're creating some validators for it. What you could do as well is you could create like you could just create a list of validators that you could constantly apply. You could say like levels validator, level validators, and then set that equal to this list, like somewhere up here, and then let's say that you end up using that list multiple times, then you can just say that the validators, well, we don't really have another field for it, but let's say that the description had the same validators. Then you could reuse those validators every time by saving that list as a variable. But in this case, we're only using the levels validators once, so it doesn't really make sense to put in a new variable for them. So we can just basically chuck them into the line and make it a little bit longer. Does that answer your question, Abu?
Yes, thank you.
Mark, I got a quick question. So the models dot email field that restricts it
Right.
to an email. Then I remember you seeing showing the email validator. What's the fundamental difference between restricting that field to like an email field under models dot field and email in the validators? Does that make sense?
Oh, that does. I'm actually not sure, but let's see. So email field. So I know that you can use the email validator in Django on like a regular text field. But let's see. Here we go. All right, I'm going to put this link in the Zoom chat to help answer your question. But basically, the email field is a regular character field that just automatically has the email validator on top of it. So normally, like if you just had a regular character field, like let's say, we could say like email is, so we can either say models dot email field, or we could also say that email equals models dot character field, and then say that validators is v dot email validator. They basically do the same thing.
Got it. Thank you.
Any other questions?
Omar, I know
Yeah.
we talked about SQL injection a couple days ago. So would this validation prevent that from happening?
In theory, but it depends on how good your validators are. So, for example, like in the name field, for example, if you have a SQL injection query that's more than 200 characters long, it won't let you put that in. Or, similarly, but you'd still be able to inject into, name or description if you wanted to. But what the validators aren't necessarily designed to help secure your website, I suppose. They're more designed to just make sure that you're putting the right data types into the places they need to go. So like level, for example. Level, we only want to restrict it to being between 1 and 100. So it's only going to say, because the integer field, it's going to say like, hey, you can only put numbers in here. And the validators say, you can only put numbers in between 1 and 100. That's really all validators do for us. They aren't really a way of making the website more secure. So in terms of preventing SQL injection, kind of, but if you really want to prevent SQL injection from happening, then you need to start like custom coding either validators or things that check the input before running it and stuff like that. So hopefully that helps.
Yeah, thank you.
Any other questions? Okay, so going back to the topic, there are other validators too. So like we mentioned, in addition to email, there's URL validators, there's length, there's I think like step values as well. There's a lot of options. So for now though, we're only going to really use the min and max values, but also for our description, we can also set minimum and maximum lengths that we can put in as well. So those act very similarly to our model.character field max length equals, but it's slightly different because now it's a validator. So we could say that, let's say the minimum length that we want to use, let's say the description by default has to be, or when it's not a default value, it has to be either more than 25 characters and less than, I think it was like 150 in the example. So what this will, even though our default, this is nowhere near 25 characters long. But what the validators do is the validators don't check your default value. The validators will check about when you input something or custom set a value, is that in accordance with the guidelines that we're giving or not? So, and even though this does not fall within our validators range, it's still fine because that is our default value. Let's see. That's about it for default validators.
Does that apply to the admin adding things?
So that's what we're going to test very shortly here. So give you like 3 minutes and then we'll see.
Sorry.
Oh, you're good. But if you want to early answer your question, the answer is yes. But we'll see it in like a sec. So now that we've created our model, we can go ahead and do our migrations. That doesn't do anything. We can migrate our changes. There's nothing to change, which is good. And let's also go ahead and run my web server. Let me copy this into my browser here. Open my browser. Where did my browser go? And there it is. All right, so now I'm in my browser here. I can go to my admin panel. I'm already logged in as my super user. I can go to my Pokemon app, and we can see here I have 2 Pokemon showing up in my Pokedex. I have a Charizard, which is this guy, and I have a Pikachu. So let's say that I want to change my Pikachu's level to some like ridiculously giant number. So if we remember, we set the level to only go from 1 to 100. So if I change that level to like 12,000 and I hit save, ta-da, we get errors, which is beautiful. And the errors that we get are, the first one says, ensure this value is less than or equal to 100. Oh, that's easy. I'll just set this as like a negative number because a negative number is less than 100, so that should be fine. And ensure this value has at least 25 characters. It has 6, so we could say unknown, but Pikachus are Pokemon that are fluffy. That should probably be more than 25 characters. So if we save it now, we still get another error, and it says ensure that this value is greater than or equal to 1. So okay, fine, we'll set the value of this guy as like 30. So okay, 17. I don't know why I typed 17, but 17 works. And we can save that. And now we see that the Pokemon was changed successfully. We can go back in and we can see, all right, the name is Pikachu, the level is 17, and we have a nice long description. So we can also add a new Pokemon. Let's say that for a new Pokemon, we could call it, I do not know the names of any Pokemons off the top of my head. Let's just type in some random characters. And go ahead.
Gengar.
All right, I'm going to assume I'm spelling that right. If I'm not, I'm sorry to all Pokemon fans out there. All right, so the level of this guy, again, let's set some random things, see if we can trigger our errors when we create our Pokemon. So we can go, let's say, big random number. We can set the date encountered to like random date. Let's also like mess up our date a little bit and put in some other characters like this 0.5 AA. Let's see what happens. Date captured. Yeah, we can do today and now, which is going to keep updating. And description, let's leave it as unknown. And let's see what happens. So again, this is a brand new Pokemon that we're creating. It doesn't exist right now. If we hit save, we get a bunch of errors thanks to not just our validators, but also our form definitions. So the name is fine. The level, okay, fine. It needs to be less than 100. We'll change it to 35. Apparently putting decimals in dates is not a valid date. So we can just delete that, and that should be a valid date. And again, our description here is set to unknown, but we need to ensure that the value has at least 25 characters. We could say unknown, but this is a Pokemon. Someone told me it exists. And if we save it now, we see that Gengar is yet to be caught was added successfully, and it does exist. But this exists in our admin panel, which is great, but our admin panel is not necessarily the same as our SQL database. So what we want to do is double check that does this stuff indeed exist in our SQL database. So for that, I'm going to find my Pokedex database. We found the Pokedex database, and I'm going to just go back in and select star from my app. And we now see that we have the Charizard, we have a Pikachu, and we have a Gengar. And they all have characteristics that we added in there. So that is the very quick summary of how built-in validators work. Are there any questions about built-in validators before we move on to something very slightly different?
I have a quick question. So once you enter that class within the admin, your defaults are going to have to be changed if they don't meet the validator.
Yes.
Okay. Just making sure.
But note that for our earlier instances of the classes that we made, so like the Charizard and Pikachu ones, those that old data doesn't get thrown out, even if it's not within the validator's constraints, because the validators only apply when you're creating a new item in the table or editing an existing item in the table. It's not going to do anything if you just have data that's there. So that's something to keep in mind.
Are you able to put a placeholder that isn't taken in as input?
That would be your default value. So the default value isn't something that you input on your own, but if you basically don't change it, then that's what gets input.
Okay.
So if you wanted these validators to apply to the old data, would you have to delete the old data and then do it again with these validators?
You wouldn't have to delete the old data, but at least in the admin panel, what I would suggest doing is basically what we did with the Pikachu, and just basically going to edit and then saving it. But then when you save it now, because you went in and edited it, it's like, whoa, it doesn't fulfill any of the validators. So that at least is personally what I would suggest.
Thank you.
Any other questions? So we're not done yet because there's still more material to cover. Number one, our name field. This is something that we didn't really touch. Right now, do I have any validators on my name field at all?
No.
No validators. So it would be technically possible for me to create the name of a Pokemon that has special characters, things in other languages, and potentially some SQL injection code. That is not good. How can we change that? But also, Django doesn't really give us any validators to specifically check what a Pokemon name looks like. I mean, it tells us like there's validators for rejects, there's validators for URLs, for decimals, but nothing for a Pokemon name. So we kind of need to change that. So in order to do this, I need to go ahead and create some validators on our own. So whenever we create something that's not something that should be included in the same place as something else, we want to create a new file. So in my case, I'm going to create a validators.py file that's going to contain all of the custom validators that I eventually write for my Pokemon app. So it's really good to have this sort of compartmentalization. And I mean, if you think about it, like you've got, your admin panel that only the admin.py that only has the stuff for the admin site. You've got your models.py that only has your models. You've got your tests that only has your tests. Your views that we're not going to use right now, but that eventually will only have reviews. And maintaining this format is something that I highly, highly recommend. So let's describe our file first of all. So what are validators.py? We can say custom validation fields for our Pokemon models. So if we go back to the models here, remember that we imported validators which are our default validators from Django.core. Now, if we want to make our own validators, we don't import validators the same way. Instead, what we have to do is say from Django.core. It's already going to the exact same place. Oh, that should not be a space. But instead of importing validators, we're going to first import exceptions and then import a validation error. Now, what is a validation error, you may ask? Well, if we go back to our models here, remember when I was typing in those random numbers and letters into the level field and it was throwing errors that said, hey, the maximum value you can have is 100 and the minimum is 1? Those errors were a specific type of error that were called validation errors. That's really about it. So that's the reason why we use the reason why we also use validation errors instead of just generic like type errors or input errors, etc., is when we actually start designing our front ends, we can specify how we want validation errors or other errors to show up in HTML. So we can have them, for example, instead of showing up with just like a little bit of red font, we can have it show up with like a bright red pop-up and a bunch of like warning bells or just not show up at all. So we use a special type of error in our validators because they're validators, so they're validation errors. The next thing that we're going to do is, well, first of all, I want to create a validator for my Pokemon names. So what's something that we're probably going to end up using when we create a validator? Well, regex is never a bad choice. So because again, we're doing stuff with a text string, so I might as well just import regular expressions or importing RE. And now we can start writing our validator function. So one thing to keep in mind is when we're creating validators using the Django validators, the min value and max value validators here are classes. However, when we are going to write our own custom validators, we're going to be writing our own validators as functions. So I'm going to note that here, create a function validator. And let's call this one validate name. Just, keep it really simple. Now, obviously, when we're creating a validator function, the function needs an input because it doesn't know what it's going to validate. So we can create a name for our input. Now, let's see, what should we do next? Well, once we created our name, we probably need to figure out what the proper format of our name should be. And this is where the regex comes in handy. So what we can say is we can say like name pattern. And how do we define whether something is regex or not in Python? Does anyone
Squiggle.
remember? Okay, squiggle's one way. What's the other? Remember, it's really similar to an F string.
The G,
Close.
is it a raw string?
It's basically just saying R and then your string. So the R here signifies that this is a regex pattern that is related to the regex module. That's about it. So we can create our regex string, and let's say that I only want my names to have, I need it to start with a capital letter, and I need it to have a bunch of different characters after.
Bracket A to Z to start with.
Yep. And okay, so Nick, France, and Ethan. Okay, so regex is the same thing across basically all languages. Or let me rephrase that. So the syntax of regex strings is the same thing in JavaScript and Python. It's just how we use it that's a little bit different. And that's what we'll get into in a couple minutes. So if we wanted to create a regex string that just has, let me write this down. You could say alpha, or no, well, not even alphanumeric. Only letters start with capital. So the way we can do that is, as somebody already alluded to on mic, I do not remember who, unfortunately, but first we need to denote the start of the string using a caret. Then we can say that we want to go from A to Z, which is our capital letter. And then after that, we want to go with lowercase letters, and we want to have an unlimited number of our characters. So then we can use the star for that. So hopefully this format, oh, I forgot, we need the $sign because that's the end of the string. So hopefully this regex format looks relatively familiar to you guys. I know it's been a little while since we've done it, but this is just the basic normal regex pattern format. So now that we have our regex format though, how can we use it? Well, remember that regex stands for regular expressions, which creates patterns. And we need to double check that our name is in accordance with our name pattern. So to do that, I can create something that double checks. So we can say, does name match pattern? And to check that, I'm going to use the regex module and then say dot, and there should be a match function. And the description of the match function is it tries to apply the pattern at the start of a string, returning a match object, or none if no match was found. So what's our pattern? Well, our pattern is going to be name pattern. And what's the thingy that I'm trying to match? What's the string? String is name. And what this will do is this will tell us, is the pattern in the string, or more specifically, is name formatted in accordance with name pattern? If it is, then this thing will exist. If it doesn't, then we have a problem. So, oh, go ahead.
I'm sorry. Can you say that again? What does it return? It returns none.
So it'll return. So as it says here, it'll return a match object, which is a data type from the regex module that you can use to identify, the location and what's in it. Not a normal string, and it'll return none if no match was found. But we don't need to know what the match object is. We just need to make sure that it's found or not. So basically what we can say is if found, do stuff. If not found, then do other stuff. So how can we change this format to look slightly more Python? So if it's been found, or let me rephrase. So if it's not found, then we know that this guy is going to evaluate to none. So if it is found, that means that this thing is actually going to have a value. So we can basically just check, hey, does the name match the pattern? Does this thing exist? Which basically says it hasn't been found. If it hasn't been found, we know it's just going to read none. So we can just write an else statement right there. Now, if the name does match the pattern that we want, then we can just return the name because the name is valid, it's fine. So we could say name is valid, so just return. But what if our name isn't actually valid? Now is where we need to raise our errors. So we can't return an error directly, but what we can do is raise a validation error. And here, let me actually type that again. So as you can see here, it says validation error is a type of class that gives you an error while validating your data. And there's a few things that we can input. The first thing we can do is put in an error message. So let's say improper name format. And then it also needs to take in some parameters. So we could say parameters, which is the mapping. And then we say basically the thing that had the error. The thing that had the error is the name field, and the actual value that had the problem was this guy right here. And that's how we basically create a custom validator. Again, so going back from the top, we created a custom function that takes in name as an input. We created, for in our case, a name pattern using regex. We check whether the pattern matches the name. If the name is good, then we just return the name. If it's bad, then we have to return a validation error. And our validation error has two parts. It has an error message, and it has the parameters that caused the error. And the parameters that threw the error were the fact that it had an improper name because name was that guy. Any questions about creating custom validators?
What's the difference between using name pattern.match and then re.match? Because can't you use name pattern.match since that is your regex? Not work like that.
It doesn't look like it. At least not in this case. But I think that's because name pattern right now is still just a regex string. It's not changing to a match object or something from the regex module.
Okay.
Yeah. So when running the re.match function, it basically will like apply the pattern to the string. At least in Python.
The params part of the raise validation error, that just tells the person what the error is, right?
Basically, but it more just tells them like, this is the thing that you got wrong. So if you said improper name format, that's good for the user, but the user is not going to see this bit, but that's the bit that would show up in the back end when an error happens. Because I mean, if we go back to the models, or actually no, we don't even do that. If we just raise a validation error without this, how would we know where the validation error came from? We would have no way of knowing. So the params bit tells you where the error comes from.
Gotcha. Thanks.
Kumar, I'm sorry that I missed this part, but did you make the validators.py file yourself, or did it auto-generate like a lot of the other files that we're working with?
Nope, it was custom made. So validators.py, sort of like the fixtures folder, is not something that is going to originate on its own. You got to create it.
All right, thank you.
Yep. All right, any other questions about the custom validator? If not, let's just go over how to import custom validators real quick. So remember that our default validators come from the Django core module. Our custom validator is not in the Django core module. So we need to import our validator function. So to do that, we need to go to my validators.py module. So we could say from and then dot validators, because that's how we can get to the validators. We need to now import, and remember the name was validate name. So I can go here, nope, here, and we can import our validate name function. Now, in our name field up here, we
If
can
you put
go
an import asterisk, would it import the entire file? Or would I have to specify every validator I want to import?
So personally, I would always stray away from import star just because you never know what's going to get imported with that. So if you defined, let's say, variables outside of this, or like lists or other functions, those get imported too. Now, let's say that you have two functions or two lists or two things with the exact same name, but one of them lives in this file, the other one lives in that file. You're going to get a conflict because now they'll get overridden, or Python will be like, I don't know what to do with this. So whenever you import star, I would personally always be very careful about doing that, just because those sorts of conflicts can happen. So even if there's, unless you have like a lot of imports, in that case, it makes sense.
Okay.
But yeah, so if you did import star, it would import the function too. But I would just personally like to stay away from that, just because, especially in big files, it's hard to know how much is getting imported. Okay, so now that we have our validate name that's been written, we need to add it to our name field. So in order to do that, what I can do is, just like we did down here, we can add validators and open that up. But now we don't need to do the v dot, because remember, the v dot was for our default validators. Instead, I can just write the name of my validate function, which is validate name, and save that, and we're good to go. That's how we can validate our functions. Any questions about the validators? How they work, how we can create our own, how we can import them, use them. All right, I'm gonna assume there's no question on that.
Sorry, just for
go ahead.
Just for clarification, you don't need to pass the name because it's already on the name line as like a parameter for the validate.
Yes.
Just automatically pick it up.
Yes, but more so than that, the validate name, we're passing in the function itself. So we're not passing in the field that it applies to. Inside the validator, we're just passing in the function. So that's the other reason why we don't specify that it's acting on name. Any other questions? Robert, you definitely could. Now that dictionary would probably be pretty big. So what I would personally do instead is create like a CSV or a JSON file of all, or a text file, honestly, of all the Pokemon names, and just go line by line through that and like import the file or read the file, should go check every line, see if the thing is included in there. If it is, you can put a check mark, and if not, then you can throw this in. So yeah, that would work too. All right, so let's see how much other stuff we have. There's not very much left before I send you guys off to do exercises, but would you guys like to take a short, like 3 or 4 minute break and then come back, or do we want to just blaze through for the next like 10 minutes or so? It's up to you guys.
Break.
Break? Okay, sounds good. Here, you know, we'll make it a 10-minute break just to be a little bit more fair. So we'll come back together at 10, make it 10:06. Awesome. All right, so we just finished talking about how to use validators, create validators. That's about it. But validators are great. As we saw, we can use them to validate our data. But there's one other step in the model creation process. So remember, we created our models. We've learned how to write validators for them. We've learned how to migrate and move our models to SQL. But just like any good programmer, we have to also test our models and our classes. So for that, we need to use the tests.py library. So thankfully, Python or Django gives us a way to test our models using the tests.py file. That should be something that's available to everybody by default. If not, you'll have to create one, but pretty sure that Django will always give you a test.py file when you create an app. So to do this, to test out our models, well, we obviously need to import our models. So we could say, what was it, from .models, import Pokemon. And then we also need to import our validation errors as well. So we could say from Django core exceptions, import our validation error. Because the thing that we're testing our models for is we're testing our validator files, our validator functions. So now we need to write a test class for our tests. So following standard format, I'm going to call this Pokemon test. And this is going to be a subclass of our Django test case class, which basically just lets us write test cases and lets Django run them. So we have a couple of tests that I'd like to run. The first one is just making sure that this guy can create a Pokemon instance. So we'll say define test1 by using test1, and let's come up with a name for it. I think the name that I'll use is create Pokemon instance, which is basically what's on the README. Now this is going to take in self as an input because that's how we define our functions within a class. It's not going to take in any other inputs. And I'm going to create a new Pokemon. So let's make a new Pokemon, and we can create that by saying new Pokemon equals Pokemon. Does anybody else have a Pokemon name?
Charmander.
Okay, I've heard of that one and I know how to spell it, so we'll do Charmander. So we'll create Charmander, we'll set that the name is equal to Charmander, and we'll say description equals this is a Charmander. It looks like a piece of lettuce. And that should be about all we need for our description. Oh, I guess could probably use single quotes instead of double quotes for it. So we created a new Pokemon. Hooray! Are we done with our test? No, we need to make sure that our test actually, that the Pokemon actually makes a real Pokemon. So the first thing that we need to do is run our validators on the Pokemon. So the first thing that we need to do is try and accept. So try accepts are basically where Python will try running some code, make sure that the code works. If the code doesn't work, then it moves on to the accept loop. So the first thing that we want to do, oh, actually, I think I probably should have covered this. Did I go over the slides for why we test things, by the way? Or did I miss that? Okay, well, that probably should be something good to talk about before we actually jump into writing tests. So back to, okay, hopefully you guys can see my browser again. Okay,
Yes.
so there we go. So, and Francisco, thank you for the reminder. So the reason that we also write tests is it's the same logic for why we write tests for our class. Number one, it lets you catch errors before they show up in production, which is big no-no. It helps you ensure product quality by creating a standard. So if you write tests for all your classes and you write basically similar tests for similar classes, it puts all of them up to the same standard. And it also helps you refactor, add in new features. And it's also not a bad idea to test your functions or classes every time you update them. So also, testing is done after migration. So if we go back to that 4-step model that I talked about at the beginning, we're going to create the model. After we create the model, we're like, okay, I have my model. How do I make sure that the correct things are being put into our model? We use validators. Then we say, okay, I created my model. I've created my validators. How can I put this model into SQL? And we can migrate it over using make migrations and migrate. And once it's in our SQL database, we can say, okay, now that our model's in SQL, let me make sure my model actually works. And to do that that's where the testing part comes in handy. So we'll check that our fields, our validators, and our methods are working with proper input. And there should be an E here, breaking without receiving or when receiving improper input. And that's basically what we're going to check now. So let's go back to our test file. And this is where the try and accept bits come in handy. So there we go. Okay, so the try bit basically says Python will try running the code inside of this. If it works, then that's perfect. We have absolutely no problem. But if it tries and fails to run the code, /errors happen /. Basically, if it doesn't run normally, then it's going to do whatever is inside of our acceptable. So let's run our try first. So one thing to note is I've created a brand new Pokemon here. It's Charmander, it's got a description. By creating the Pokemon on its own, the validators aren't going to run. When we create a new instance of our model or of our class in Python, the only time a validator is going to run is if we run the full clean function on it. So say this is necessary for validators to run on new instances. I think that the README for today talks about why in a little bit more detail, if you guys are interested in doing that, but it's not super important for us right now. So once we run the full clean function, our validators are now applied to our brand new Pokemon instance. And now we need to make sure that our instance is actually created and used. So in order to do that, we'll say self.assert is not none, because we want to make sure that the instance is actually created. And we say new point. Let's see. If you don't test, then validators are useless. I don't know if I would necessarily say that, but what I would say is validators are useful for checking that your input is not a bad input. If it's a bad input, the validator is like, yeah, this doesn't exist anymore. Which is why we want to test our validators to make sure that it removes all the bad inputs and that it checks off on good inputs. We just ran validators in our admin panel without testing. So even though we didn't test, the validators still worked and are still useful. But testing helps us make sure that our validators are doing the right things. Does that kind of make sense?
No,
And also, are there any questions about why we're testing our validators as well? Okay, so back to the try except. So again, Trython is gonna try running the code inside. It's gonna say, all right, I want to fully clean the Pokemon out, and I'm going to apply my validators to it. And then why am I running self.assert is not none? That seems a little bit strange. Well, let's say that our Pokemon throws some errors. Like, let's say that Charmander is not an acceptable name for our Pokemon. Remember what happened in our admin panel when I tried putting in things that didn't match our validators? Was our Pokemon added to our database when I did stuff that did not validate properly? Okay, maybe not. Here, let's go back and rerun the server here. Here, let me comment. Let's comment actually all of this out right now. And run server, go back to the browser for a second. Okay, we're back here. So right now I've got my 3 Pokemons in my browser, right? So let's say that I'm going to create a 4th Pokemon, and let's say that I'm going to mess up the name, for example, and I'm going to save this. Now, it shows me that I'm getting some errors, right? It says improper name format, and ensure this value has at least 25 characters. But has this actually been added to our Pokemon database? We go back, it's not added. Why? Because when it throws the errors, it basically stops the object creation process. And it basically puts it on hold. The only time something gets added to your database is if it passes all of your validators. Even if one validator throws a validation error, it is not going to put it in your database. So going back to, well, first off, before I go back, does that make sense to everyone? So going back to our, okay, okay, let me go back and run through it again. So create a new Pokemon, and again, let's put in some random thing in it, and I'll hit save. Now, when I hit save normally, the Pokemon should go into my database. But because I have errors in the Pokemon, it's going to say, all right, hold up. I can't add this to the database because this is not formed correctly. If a validation error shows up, it is not going to show up in your database. And we can go back here and see that we still have the 3 Pokemons. It hasn't added my Pokemon with this weird name format. Versus, if I change the name format of this to be something correct, and I change this to also be something correct, we save it. Oh, right, this needs a capital letter. We save it, and this one does indeed get added. And it says up here, the Pokemon was added successfully. But when we had errors in our Pokemon, when it threw validation errors, it would not be added to your database. So I'm going to delete this one for now. Yes, let's delete that. But are there any questions about that? About why we're using validators or how they work for us right now? And did that clear up the questions that the person who spoke before had?
Yes.
Okay, perfect. Any other questions about this before we jump back into the testing code? Okay, so back to the code. So going back to Roger's question about where did the assert is not none comes from. So what we just did in the admin panel is we created a new instance of our Pokemon. And then we apply, when we hit save, that applies the validators to it. Because remember, the validators are basically the things that check all of your form fields. And it says, all right, is the name good? Is the other fields that I included, are those good? So when we run full clean, remember, if the validators successfully pass, then new Pokemon is added to our database. But if the validators fail, so remember, when our validators failed, was our Pokemon added to our database? No, it wasn't. So new Pokemon not added to database, which then means that the model creation fails. So model creation fails. That in turn means that new Pokemon becomes none. Right? So again, new Pokemon here is supposed to be a Pokemon model. When it's a Pokemon model, that means that it goes into our Pokemon SQL database. If it was created successfully, it goes into our SQL database and new Pokemon is still a Pokemon. But if it doesn't pass our tests, it's not added to the database. And when it's not added to the database, the model creation fails. If the model creation fails, new Pokemon is none. So this is where the self.assert is none comes in handy. So we need to check self.assert is not none and check that for a new Pokemon. Now, why? So if it is not none, then that means our new Pokemon was successfully created. If new Pokemon is none, then that means it wasn't successfully created, which means our validators failed, which is where we have the problem. And that is where our except block comes in handy. So if it fails to run the code, meaning if this assert is not none goes wrong, then we need to say that this thing has failed. So we run self.fail, and we're not going to put a message on it right now. Oh, let me also just equip my admin. So does the first test make sense? Any questions about that right now?
I kind of forget the difference between within your accept block, if you just have accept or if you have validation error as E. Do we need to use that validation error as E, or is it like, does it not make too much of a difference?
So if we were to type that in, accept validation error as E, that basically introduces a new variable for us that we can use inside our accept block. So if we were to include this would say, all right, I know that I am accepting because I have a validation error. Let's call that validation error E. Now, what we can do with that validation error is we can print out the error message. So we could say print E dot, and this is going to be message dict, and that's going to print out the validation error that was thrown. So that's the only reason why you would want to include the accept validation error as E in here, so that you can print out the message from it in your console. But we don't need to include that if you're not interested in printing out the error message.
Awesome, thank you.
Any other questions about this test specifically?
Yeah, I have a question, Umar. You might have addressed this already, but if we just used try and then in the try block, we tried to create a new instance of that Pokemon. If we entered a parameter that did fail, wouldn't that raise an error on its own?
It would. No. So that's why we have to run the full clean function. So if we were to just create a new Pokemon right here using the name and description, the validators would not run. So if we go back to our models, the only time, and we have all these lovely validators in place, well, the only time our validators run is in my admin panel if I hit save. If in my admin panel if I hit save, or if I run the full clean function here. So if we just never ran this full clean function, the validators would never run. So the Pokemon would, the object would still exist, even if it was not properly created. In order to fully create it and run the validators, we have to run the full clean function. So yeah, Jonathan, the full clean basically acts like a save function for our purposes.
That makes sense.
Or I guess if you want to be more specific, it cleans like all of the fields within that model and cleans them by checking over one thing. Okay, any other questions about this specific test before we move on to talking about how I can test things?
So you're just talking about the test, right? Like the validators will only run within the test if you do the full clean function, but outside of the context of the test, the validators will run when you're putting in inputs. I think that's what was confusing me earlier. Is that right?
Yes, pretty much.
Okay, thank you.
All right. So if there are more questions, again, please feel free to raise them. In the meantime, though, I'm going to go ahead and show you guys how to test. So we've created our Pokemon test class, and we've created a singular test with it using our sample Charmander with that looks like a piece of lettuce description. Now that I've created my Pokemon test for my test class, I need to actually figure out how to run my test. So in Django, whenever we're running tests, there's a standard format for doing so. And we can do this by make sure that you're in the same directory as your manage.py. So I'm in that one, and I can check that if I do an ls, and I see here, yes, manage.py is included. So I'm going to go to Python and manage.py. And now I'm going to run my tests by just saying yes. It's not overly complicated to run tests in Django, thank goodness. So if I hit enter, it runs it really quickly. So let's walk through this step by step. The first thing it does is it goes to our test.py file. It goes into our class and it says, all right, I see one test case, which is test1 create Pokemon instance. It's going to create a test database. So remember how we have our Pokemon database that I connected to in my settings.py, which are the Pokedex database, which is here. When we're testing, Django does this really nice thing for us where it creates its own test database that it runs all its tests in and then deletes that test database after. So that helps us out a lot. So it creates a test database. It system checks. It says that there's no problems with my system. Then it runs this test, makes sure that the test works. And if the test does work, then we're good. If the test doesn't work, well, it did work. So once it works, it will destroy the test database and we're done. So this is what happens if your test runs successfully. Now, let's run a second test, and let's call this test to create Pokemon instant, and we can just say Pokemon with a bad name. And instead of Charmander, we're going to change this into that, and we'll just say a silly message like, this is a bad Pokemon, and more than 25 characters. Yeah, it's more than 25 characters for sure. So remember, our name should not have numbers in it. It should start with an uppercase letter and have a lowercase letters everywhere else after them. So it's going to try cleaning the Pokemon, and that basically again means that it's going to try running our validators and saving this. If the validators pass, then the Pokemon's added to the database. If the validators fail, then this should tell us none, right? So this should really clearly fail, because we go back to our validators. Remember, we created a validator for our validate name that only takes in letters, and we applied that to our model right here. And if we go back to our tests, this should not fit that validator. So then it'll assert this will be none. And when that becomes none, because again, the validator is going to fail, and in our validator function, we said if it matches a pattern, return name. If it does not match the pattern, which ours does not, it's going to raise a validation error with this name format. So if we go back to our tests, again, it'll tell us that this thing is none, and it's going to throw a big validation error. Now we go to the accept block, and it says, all right, I know that I didn't run this thing correctly, but I also know that I got a validation error. So let me take that validation error out, assign it to a variable called E, and then I'm going to print out the message attached to that validation error, and then it's going to fail a test. So let's try running this and see what a bad test looks like. So we run this. Let me make the terminal bigger so you guys can see everything. So this is, again, I'm running two tests now, one good test and one bad test. So I'm saying Python manage test. It found two tests. It creates that test database, no system issues. And then it says that the name has an improper name format. And we get a big old F. Why does it give me an F? Where? Well, that's where the next line comes in. It tells us, all right, we failed the second test. That creates a bad Pokemon name. Where did it fail? It fails here at the full clean. Why is it failing at the full clean? Because that's where we run our validators. What sort of error is getting thrown? We're getting a validation error right here. And what's the validation error? And why is it showing up? The validation error shows up in our name field. And what's the error? The error is that there's an improper name format. And then because I ran self.fail, we also get an assertion error down here. So in summary, if all of our tests work, we should see something like this, where it just has dots, says it ran one test, and then it shows us an OK. If we have a test that fails, it will output and we tell it to output our validation error. It will output the contents of that error. It will tell you that the test failed, and it'll tell you exactly where your test failed as well. And that's it for Django testing and validations. Any questions about how testing and validations work?
What if we know something's going to fail and we want to make sure that it's failing properly? Like, can we test for a failure?
That's basically what we just did with the second test here. So we designed it so that we created a bad name. Then we ran the full clean. Because it's a bad name, we specified in our validator function that's going to raise this validation error. So what we're looking for when we run this test is we're looking for that validation error to show up in our console, which we can see here, it does.
But I'm saying, like, you would want it to pass the test, not fail the test. So we want it to test that it's going to pop up a certain thing if it is wrong. So if it does pop up what we want it to, it would technically still pass.
Okay, I
If
think
that
I
makes
see what you're saying. Yeah, it does. Um,
Are you saying like put the self.fail in the try block?
Go ahead.
Is that
I
what
think
you?
that would I think that could work. We could also probably try just doing assert is none. Let's see if that does happen. Nope. Okay.
Could I jump in here real quick, Umar? I apologize.
Please, yeah, I was gonna ask.
Okay, perfect. Yeah, so technically speaking, you guys are correct, right? We want this to ensure that it does fail, and that's exactly what we're testing for. We're testing that it fails. So essentially this test should pass. So what we're gonna do is in line 33, right? We're gonna grab that self.fail and we're gonna move it up to line 28. Because if this gets created, meaning that full clean doesn't throw a validation error, well then that means my validators aren't working the way that I want them to. So now we could just comment out line 29 because line 29 isn't going to be triggered at any point. But now the next thing that we can do is on line 33, what we can do is we can run an assertion on that message or that the validation error that we're receiving. So if we scroll up on our terminal, we'll be able to see that validation error. So now we can say, well, self.assert, and I believe that's the correct syntax. Yep, it's just assert with an underscore at the end of it. Perfect. I think yeah. And now in the parentheses, we're going to pass the argument of what is it that we want to assert. So we could just grab that message straight from the terminal that says improper name format. And we need to make sure that it stays in quotation marks. Perfect. And then we're going to say, I want you to assert that this is inside of e.messageDict. So the other way around, could you put the e.messageDict on the right side, please? So e.messageDict, and then after that, we want to make sure that we access the key of name, all right? And then instead of that comma, could you switch out the comma for in? Right. And the reason why we're utilizing in is because, well, at message dict, which is a dictionary, at the key of name, we have a specific data type, right? We have a list. So me saying that this is equal to it would definitely fail. So instead, I'm going to check that the list actually has an instance of improper name format inside of it. And now when we run our assertion, we should go ahead and see that both tests pass. So now we see that 2 tests passed. I think we have a print statement on line 32, and that's why we see that dictionary still popping up there. But when we run it again here shortly, we'll just see 2 dots populate, and it's saying that all the tests ran okay. And that's how you check for improper input versus proper input. I apologize, Umar. Thank you for letting me take over there.
No problem. Thank you very much for that answer. So yeah, Ethan, hopefully that helps.
Yep, that was exactly what I was talking about. Thank you.
Any other questions about testing or validators?
Yeah, I got one more. So outside of test, where would we be using a full clean to do the validation check and then adding it into the database? Because I think with test, we'll test it and then it drops the database, so it's not saved, right?
Right. So Francisco would probably know more about this than I do, but from my understanding, you'd want to use full clean and save. Basically, whenever you create a new model in Python and you want to put that in the database, the way that we would put it in the database is by running the full clean function or running the clean and then save functions. Francisco, does that sound right?
Yeah, so full clean is doing a couple of different things. I put it on the chat, and essentially full clean takes in a couple of different functions that Django has built into it. One of them being the clean method, and the clean method is what actually raises all of our validation errors. So it makes sure that all of our data is actually clean, and that's why it's called the clean method. And the full part comes is it doesn't only check validations, it checks any other form of restrictions that we may have that's applying to this specific model. Once it checks all of that and it all comes back clean, then it automatically saves it onto our database. Now, .save does not raise validation errors. .save just grabs things and puts them straight into our database, even if it doesn't meet our validators. And it's essentially a way to bypass validators if, let's say we have a special edge case where we have to, account maybe for someone who has a really, really long name, but our data field doesn't allow for anything more than 20 characters. Then at that point, we would have to treat that manually by utilizing the .save method. But full clean is essentially taking both clean and .save, combining them together. So it first checks that all of our validations and all the data is clean, and then throws it into our database by saving it. Does that answer the question?
Yeah, thank you.
Of course.
Or any other questions?
I had a question about the validator. So when we get when we're inputting an email or something like that, and it bounces back with, "Hey, this email doesn't exist." Is it like pinging the email address to see if it actually exists? Like if you mistype it and it says it doesn't exist? No.
Nope. That would actually be really cool. But unfortunately it doesn't. So all it does is it basically will check the format of your email. So it'll be like, all right, and does it have a text thingy at the start? Does it have an @ sign in the middle? Does it have a dot and then something like a com or a net or edu or whatnot at the end? If it checks all of those little boxes, you've got an email. It does not check if your email is a real email or not.
Oh, I got that. I just meant in other instances, like I'm pretty sure I've used other websites where it's like, this email doesn't exist. I'm like, how does it know that it doesn't exist? I mean, obviously my thing's wrong because I left in OAuth or something like that, but how does it know it doesn't exist?
Yeah, so for that, just like Francisco said in chat, that one would use some sort of third-party APIs. So for like different email services. So like if you could have one for like Gmail, one for Outlook. I'm pretty sure Yahoo has something as well that basically it won't give you access to all of their emails because that would be a massive security breach. But basically you can call an API or their function that basically says, all right, I'm going to send you an email. Can you just double check that this email exists in your database for me? Then that function will run that test and then it'll tell you, yep, it exists, or no, this doesn't exist. That's about it.
Okay, so it wouldn't be in the validation function. It would just be the input would trigger a different function.
So that wouldn't be in the default validation function, but just like we wrote a custom validator for the name field, you could probably write a custom email validator function that incorporates that in there as well. Which I wouldn't be surprised if that's what the websites that you were mentioning were doing.
Cool, thanks.
Anything else before I send you guys off to work on the group exercise for today? All right, if not, I'm going to go ahead and get started. And let me share my screen. Where'd it go? Jake. All right, cool. So hopefully everybody can see my screen now. We're going to go back to creating a new app. And that's going to be the goal for us to finish off before lunch kicks off. So the first thing, why do we need to create a new app? Well, we have a Pokedex, which is great. And we have a bunch of Pokemon in our database, but having a bunch of Pokemon isn't really useful. We need to actually be able to do something with those Pokemon. And that's where our Moves app is going to come in handy. So Pokemon can fight and have movement cards and abilities and stuff. And we want to create a database that tells us what those are and how we can use them. So we're going to create a new app called the Move app. So make sure, first off, that we are in our overall directory with manage.py. So I'm going to clear my terminal real quick, and I'm going to list everything out. I'm in the same directory as my manage.py. So I'm going to, in order to create a new app within my Django thing, I'm going to run Python manage.py, and then we're going to say start app, and I'm going to call this app the Move app. So we run that. I get a folder over here that has Move app. It's got an admin, models, tests, and views, which is exactly what we're looking for. So whenever we create a new app, just as a refresher, we need to go back into our Django project directory and add that app to our list of installed apps. So we'll go here and we'll call this one that was named Move app. We'll put a comma. And in general, it's good practice to name your apps with _app, just so that you know that it's an app. It makes it a little easier. That's about it for what we need to do in order to get started. Then, that wasn't supposed to happen. Inside of Move app, we should get started by creating some models. So also note, Move models.py is in both the Pokemon app and the Move app. The nice thing that VS Code does when we have two files with the same file name is it tells you where those files are. So for example, let's say that I forgot if I'm editing the Pokemon models or the Move app models. Well, if you look at the top of my screen, it says here, this models.py is within the Pokemon app, and this one is within the Move app. So that's a feature that is really handy in Django and VS Code in general. So I highly recommend just keeping track of that when making your apps. All right, so what do we need to do when making it? Well, we can basically copy paste most of this stuff over. So we've got our models in there. We should probably import our validators just so that we have those up and ready to go when we create our function. So we could say from Django.core, we can import our validators as V. We should also probably import validation errors just in case. So we can say, let's see that here, from Django core exceptions, we can import validation error. And we can close that for now and close this guy. And we'll leave it here for now. So let's go ahead real quick and make a Move class. So remember that for whenever we create a Django class or a Django object, it's going to come from everything that we have in models. So it's going to inherit from models.model. And now we just need to set up our fields. So the first thing we should probably do is create a name field. So we can say that this is going to be models.character field. Well, let's set up a maximum length for it. Let's say this is 250. We can also say that this should never be blank and not null. And you'll remember that this looks suspiciously similar to the same thing that we wrote in the models.py for Pokemon. And it's basically the exact same thing. So we've got our models, our name. We should also, for Move, I think, let me just look at the README real quick here. It has another few things that we should add. They want us to add in an accuracy field. So the accuracy has to be a positive number. That's going to be a percentage. And it's going to be between 1 and 100. We are not going to deal with negative percentages here. So if we were to go back to our fields and we go all the way down to the bottom, because there's a lot of fields, we see here that there's something called a positive integer field, which is basically a regular integer field, but with a validator that says, check that this is a number bigger than 0. So we can create a positive integer field. We can set the default accuracy to 70, and we'll leave it there. We won't add our validators just yet. We'll do that after we create our whole model, following that schema that we talked about. Then we can talk about our maximum power point, or max PP, which is going to be a integer field, and we'll set the default for this to be 20, and we can set the power points value to be another integer field, and we can set the default value for this to be equal to 20. And then lastly, at the end, we might as well just add in like one more field because we already have so many. So we can say that each move has a power level associated with it. And then that would be another positive integer field, because it doesn't really make sense to have power that's a negative number. So we can make a positive integer field, and we can set the default power to be 80. So we have our class now, but we might as well also create some methods for it. So we should probably create a string method. That's never a bad thing to make. So I'll make my string method here. We'll put a self in it. And now we just want to return something that tells us about our move. So what we could probably do is make an F string. We love using F strings in our return statements. We can get, say, the name of the move. We can get the accuracy, which would be self.accuracy. We can return the move's power, which is self.power. And then we can do and then it also wants us to get the current power point, which is equal to the current power point divided by the maximum power. So let's see, we can do divide by, and I think that should be, yeah, that should be good. So any questions about what we just did so far? So we haven't set up our validators yet, but we've set up our app, we've put it into the settings, and we're starting to create our models. Okay, I'm going to assume no questions yet. So there's a few other things we can do before we put in some validators. So we can, let's see, what can we do? We can add in a function to increase the maximum power points, because I presume Pokemon can level up a little bit. So we can say define increase max PP, and then we can say the self, and then the amount that we're going to increase it by. And this is pretty easy to do. We just need to say self.maximum power points is self.maximum power points plus increment. Or if we want to be even fancier, we can literally just say plus equals increment, and just to keep it all in one line. But this goes back to something that we talked about previously for our validators. So if we just update the value of of the maximum power points in our class object, does that automatically update it in our database or not?
No, because you have to
No, unless you call it.
Right. So if we go back to our test here, remember that we were able to create a brand new Pokemon, but it would never get actually updated to the database when we created it. The only time it would get pushed to the database is when we either fully cleaned it, or in this case, we're just going to save it instead of cleaning it. So remember that from the discussion that Francisco and I had with you guys before we took the break, the save function essentially skips over the validators and just puts this directly inside of your database without checking it. And lastly, we might as well also make a custom clean function. So you can say define clean self, and this will override the clean function. So we can just double check that the current percentage power is, we need to make sure it's not bigger than the max, because if you have more power points than the maximum power points, that kind of breaks everything. So we can say max power points, and then we can raise a validation error, and we can say like power points too high or something like that. And that's about it for creating our model. Now we might as well go ahead and add in some validator fields. So we can go, let's see, for name, we should probably create a custom validator. It's never a bad idea, but in order to create a custom validator, we need to first create a validators.py file, validators. There we go. So we'll keep that. Now remember that the validators.py here is the move app validators.py. We have another validators.py in our Pokemon app that is in a different library, but the app still has the exact same name. So for our move, we can basically do the same thing as we did for Pokemon, but we'll just change this from Pokemon to move. We can change that to, oh, that should be move, not mode. Move, but obviously moves can have more than one name in them. They can be like a combination of 2 or 3 or 4, but we still want to make sure that they're still alphanumeric. So we can put in a optional second part of the name, and we can say that this is going to be A to Z and then A to Z, and we can keep that optional with an end. This is going to be only letters, start with a capital, optional second move name. And we'll change this from validate name to validate move name. And then from there, we basically just do the exact same thing. We check, does the name match the pattern? Is it formatted in accordance with our pattern? If it does match the pattern, we're good, we can return it. Otherwise, we're going to raise a validation error that says improper move name format. And then the parameters tell us where the error is occurring. So it's exactly the same thing that we did for Pokemon, but just we change up the regex a little bit, and we should change the name of the function to validate move name, so that way it doesn't conflict with our validate name from our Pokemon app. So now that we've created a custom validator, remember that we can import our validators as functions as well, using from .validators, which is our validators.py file. We can import our validate move name function, and now we can add that as a validator in here. So remember that the validators list inside of your fields need to be in a list. So if we were to, for example, write down validate move name like so, which I remember I was in some breakouts and I saw some folks doing, this will not work because you'll get an error that says, hey, I don't know how to iterate over a function. So make sure to put your validators inside a list whenever you do so. We can do the same thing for the accuracy one as well. We want accuracy to be between 1 and 100, I think. So we can set a minimum value validator to 1, and then a maximum value validator to 100. Let's see, what other things? We can copy this. And I know I'm going a little bit fast right now, but this is hopefully review from the stuff we did yesterday and also earlier today. So if at any point, if you guys do have questions, feel free to stop me or ask. So that being said, are there any questions about the setup that we're doing right now? Okay, I'm going to assume not. So just to keep going, so we're setting up our maximum power points with a minimum value of 5 and a maximum of 30. we can do the same thing here, but we don't need a maximum value for the total PowerPoints. And then for power, I think we should set a maximum validator value 120. And we have validators set for our name, accuracy, max power points, regular power points, and overall power of each move. So our functions have been written for our models. We go back to our validators. We have a validate name, so that's good. And now we're basically done. So let's go back to the PowerPoint real quick. Let me find it. There we go, Django validators. Okay, so remember that we had multiple steps for creating a model. So running through what we just did. We created our model of move, and we've created our fields, right? We created the name, accuracy, power points, max power points, move power fields, and we created some methods to go along with them. Then we added in our validators for each field, like the positive integers having minimum and maximum values, and custom writing the move name validator. So now we just need to make migrations and then migrate our stuff over. So if we go back to our models.py, let's go ahead and make sure that, let's go to our console, make sure I'm still in the same directory as my manage.py, which it looks like I am. So now that we're done making our model for the first time, we can type Python manage.py and then make migrations. Now we give it a second and we see down here it says migrations for move app. So it makes migrate because it doesn't need to make any migrations for Pokemon. And it says that make move app migrations 01 initial. It has to create the move model, which is perfect. And now once we have verified that it's made the migration, we can migrate all our changes. And now it says it's applied all migrations. So it looks like everything's in our database. So just to double check, we can go into our PSQL Pokedex database, which is our main database. And let's just make sure that we see some new database, that we see some new tables show up. Because if we don't see any new tables, then we got a problem because we just added in some models and we need to figure out where they're going. So to see all our tables, again, we type /d and we see I've got a bunch of stuff for authentication. I see stuff for my Pokemon app, which is good. And doesn't look like it wanted to make any new tables here. Interesting.
Do we have to add it to the admin file?
Admin file. Oh, you know what? You might be right. Yeah, let me just double check though. Yeah, okay, let's do that real quick. So go here and we'll type in not Pokemon. It's where did it go? Move. Okay. And oh darn it, what am I missing real quick?
Thank you.
Oh, I forgot to import. Thank you. Here, let's say from models, import. Okay, there we go. That should work now. So let me go back and rerun my make migrations and migrate just to make sure that everything is fine. Okay, so everything's been migrated over. And now let's go back into my Pokedex database, go to /d, double check that my table does exist. And it's still not showing up. Okay.
It doesn't seem to be identifying the newest change from move app. Maybe do Python match py migrate and then specify move app.
Yeah, it's still not showing up.
Let me check the settings app, settings py.
Yeah, that's my next step. Here, let's see. So it is listed as an installed app. And the database is still there.
Can I see the migrations folder for Move App real quick?
Sure. There's only one in there. Actually, I could just delete the migrations folder.
It seems like it worked.
It does, right? Because this definitely worked when I tried it yesterday. So
Yeah,
Yeah.
this may just be something going on with your machine. So maybe, yeah.
maybe. But also one other tip that I have, you don't actually need the migrations folder in Django. Like it doesn't, the only thing that it does is it saves it tells you what migrations you've made. But if you have problems with migrations or stuff starts glitching out, you're more than able to delete it, and that won't affect how your code runs. So you can rerun your make migrations and migrate stuff. And you should be fine after that.
When you rerun make migrations, can you specify Move App so it can make a new migrations folder?
Sure, let's try that one more time. Okay. So now it decides to create it. Let me see if I need to specify the migrate here as well. Let's try that now. Nope. Okay. Well, that's something I'll debug over lunch. But in the meantime, has everybody else been able to reach the stage that we're at right now, where we've got all our models created and coded up, and our validators and our the app made? Okay, I'm gonna assume so. So the last thing that we should do is add in some tests. So we should go to our tests.py and write some sample tests for our models. So those can be found in the material for today. I'm not going to go through and handwrite them right now because you guys have 2 minutes till lunch and I don't want to delay that because we have a lot of material. But here, let me see if I can copy paste it very briefly and then we can talk through it. Where'd it go? Here we go. Tests here. So all we're doing here is we're importing our test cases, our validation errors, and obviously in order to test our model, we have to import the model. Then this creates two tests. We first have to create a class for our tests called move test, which comes from the test case class. And then the first one that we'll make is a move instance that we're calling psychic. Then remember, we need to always run full clean in order to check whether, in order to add or move to a database. And we want to make sure that this move exists. If it does exist, then we're good. If we get an error, then it's going to fail the test. Similarly, we want to create a move that is going to fail the test. So remember our name, if we go back to our validator, we said in our regex, it can only have letters, not numbers. So this one, we're putting in a name that has a number. If we do a full clean on it, which again puts it in our temporary database, and we fail it, that should fail, and it should give us a validation error. And we want to double check that our validation error matches the output strings. So I know running through that was way briefer than it should have been. And after lunch, we're going to go back through this in more depth. But do you guys have any questions or feeling lost or anything about the steps that I just ran through? Resume. Okay, cool. So hopefully you guys can see my VS Code again. So I'm gonna just run through everything that I sped through really quickly before lunch, but hopefully in a little bit more detail this time around. So to start off, we still have our original Pokemon app in here, but we also created a new move app because, again, having Pokemons in the Pokedex is great, but we need to actually do stuff with the Pokemon. And the only way Pokemons can do stuff is if we give them moves. So we went ahead and started a new app using manage.py start app. We called it move app. So we created a new app, which is great. Now we can go to our settings.py up here, and we can double check that the move app is added to it. So I added the move app to the installed apps at the bottom. Then we can go to our models. I created a decently big new model for the different types of moves that we have. So we have a move model that has a name, it's got accuracy, it has maximum power points and current power points, and it also has the amount of power of the move. So for each field, just like we did for the Pokemons, we gave them all default values except the name, and we gave all of these validators. And if we remember, we have to pull the validators from Django.core, or we can write our own validators here. If we pull them from Django.core, we have to import them and then access them using the v dot notation or validators dot, depending on how you import them. And if you're just using validators that we custom write, like these guys, that we custom write, we import these, we write these up as functions that return validation errors. And then we just call those like we would put them in a normal function, just without calling the function, and we can put it in a list. So after we write our class up, we can create some methods. So we have a string method. We have something that can increase the maximum power points. And in our clean function, we need to make sure that our current power points don't go past the maximum power points, because that makes absolutely no sense. And we can throw a validation error using that. So any questions about any of the fields in the model or the validators?
What was the issue when the move app was not importing?
Good question. So that actually goes back to something with my databases. So I mentioned in class that I ran through this example last night, but when I did so, I deleted I basically deleted the table inside that contained all of the move models. So if we go to PSQL Pokedex database, and I just do /d right now, and we have, again, all of these different things inside it. Now we also have tables for the move app and move app ID sequences. So last night when I was running through this code on my own, I also made these tables and populated them, but then I just ran the drop table command after I was done with it. So when I dropped the tables were removed from the Postgres database. So I was like, okay, I should be fine creating brand new tables using Django. That, however, was not the case, because it turns out that Django itself, along with your manage.py, it sort of keeps track of all of the databases that you've created. And it hadn't fully registered that I had removed a table from my database. So when I created when I deleted that table and then today created a brand new move class and tried to push that move class up into my database, it didn't know what to do with it because it had conflicting information. So it just decided to do nothing. So the way I was able to fix it was by deleting my entire database and then remaking the whole database.
So is the I guess the learning point for us is not to make adjustments to the database from within P-SQL after creation?
Or I guess more so than that, it's be careful when deleting tables in SQL. Creating tables is totally fine. You won't have any problems with that. But deleting tables creates a little bit of an incompatibility between the Django stored history and what's in your PSQL.
Got it. So don't delete Django created tables.
Right. Or if you do, just remember delete the whole database and then put it back in.
Great. Thank you.
Hey,
Yep,
Umar,
and
can
that
you
is also-
explain? I'm sorry,
Okay.
I didn't mean to cut you off. Continue.
Oh, I was just going to say, also, that's where fixtures come in really handy, because when I deleted my whole database just now, I did not have to go in and put my data back in manually, thanks to having this Pokemon data.json fixture. So that helps you sort of keep things backed up. But sorry, please go ahead with your question.
The define clean method that you created, it's ensuring that your self.pp doesn't go over its max, and then you're throwing the validation error. Like, isn't that kind of like redundant to having the stuff up top, like the maxes and stuff?
Yes and no. So I guess you could say it's somewhat redundant, but the validators up here act differently. So these validators all have fixed values. So for example, like here I'm saying like max PP is bounded between 5 and 30, right? But note that these values are not based off of the values of PP or power or anything like that. So if I wanted to constrain the values of one of the values in my class, I would have to do that outside of these validators, and I'd have to do it in an external function. So that external function for us would be the clean function, because that's what's run basically when we're saving our data or pushing our data to the database.
Are you overriding the built-in clean function?
Yeah. So I guess it's somewhat overriding it, but also like adding this feature. So it's like while running the overall clean function, it will not only run all of the validators that are currently in here, so all of the like the validate move name and the min and max value, but it will also run this function while doing that. Good. Roger, does that answer your question a little bit more as well?
Yeah, it does. Thank you.
So
any other questions?
Sorry if I missed this. So in the tests, you still run full clean, but when is the clean function ran?
So that is run, I believe, while running full clean, because full clean kind of combines clean and save.
Okay.
From what I understand. Yeah, so I guess that does provide a good segue to the tests part. So we can talk about that a little bit. But we have two test cases that I'm putting in here. One of them is just creating like a blank move. We're fully cleaning it, and then I'm checking that this exists. Hopefully that should exist, but let me quit Postgres too. So I create a new move, I'm fully cleaning it, meaning that I'm going to check all the data inside of it, check all the validators, and then if that's all good, push it up to my database. Hopefully that works. If it doesn't work, then the test fails. And for my second test, I'm going to create a move that is a bad move because you can't put a letter inside the name. And also its point power is higher than the maximum. So that's also bad. So we're now going to try doing the new move.fullClean, which is again going to go back here. It's going to check all of these validators. And remember that full clean it runs a combination of clean and save. So it's also going to run this clean function, and it's going to throw an error here as well. So it's going to throw an error with the name, and it's also going to throw an error with the point power fix. So let's double check that this will actually work. So if I run my manage.py test, we see here that it says it found 4 tests. Huh, that doesn't seem normal. I only see 2 tests here. where are the other two tests coming from? Anybody have any ideas?
Pokemon app.
Yeah, exactly. So by default, it'll look at all of your test.pys when you run the manage.py. It'll look through all of your tests everywhere and run all of them, unless you specify for it not to run all of the tests everywhere and just to run the tests in, for example, Pokemon app, or to just run the tests in Move app. And you can specify that in the same way that you specify make migrations for a specific one as well. So it runs the tests in both Pokemon app and Move app. The Pokemon app ones we know are fine because we checked that. And the Move app ones are also fine. So we get all 4 dots. All 4 dots mean that all 4 tests are okay. And we see okay here. And the test database is gone. And that's where we should be at right now. So does anybody have questions about, any other questions about the tests or models or settings, anything like that?
How do you run the test separately, like you were saying with the migrations?
Here, I believe that this ought to work. So if you run it, yeah, so if you run it by putting the Python manage.py test, but then specify which app you're testing, then it'll only run the tests for that app. So we ran Move app, for example. Here it only found 2 tests, which is perfect. That's the number of tests that we have in Move app. And then it says, okay, so we're good to go. Any other questions? Okay, I'm going to zoom now. So let's also just make sure real quick that we can add things into our new move table. So I know we all hate doing this, but we still need to get practice with it. So I'm going to enter my my manage.py shell. Go into the shell, and we're going to create a fake, well, not a fake, I guess we'll create a move object that we will then push into our database. So we'll say from move app, which is, because remember, the folder that we're in right now is my Django demo folder, which is this whole thing. So I need to go into my move app, and then from there, I need to go to my models. Then I can import move, and we should be able to import move after that. Then I'm going to go back to my models and just double check what things I said when I instantiated it. So we're going to make a new move. We'll call it psychic. And we'll say that this move is going to have the name of psychic. And we don't need to specify anything else because everything else already has a default value. So we can create our new psychic. We should be able to, I guess we should probably save it. So we can do psychic.save. So it won't run any validators. And just for kicks, we can also print psychic. And we see here that when we print it, it runs our string method. So it tells us the name, tells us the accuracy points, the power points, and the current power point percent ratio thing. So we should now have been able to create a new psychic. So now what I'm going to do is I'm going to go into my Pokedex database and confirm that it's actually inside there. So I'm going to go ahead and double check all my tables so I can figure out what name my table has. And the name of the table I'm going to look in is move app move. And let's go out of that. So we can, does anybody remember, and if I have a table name, how can I get all of the items within that table in SQL?
You like select star from table name?
Yep, exactly. So we'll run select star from move app move and a semicolon, and ta-da, we do see that indeed the thingy that we wrote in our shell of psychic is now in our moves. So great, we were able to create a new move icon or a new move object. We can push it into our database and we can access it both inside our database and from Django. So we've now got a Pokemon model and a move model, and we have a couple Pokemons and a couple moves. So we're good to go. That's great. So now we're going to talk a little bit about connecting. So just like in SQL, how you can have tables be connected and joined together, we can do something similar, not identical, but similar in Django. So let me find my browser one more time. Where's browser? Here we go. So hopefully you guys can see the slideshow about associations now. So there's a couple of different types of associations in Django. And again, remember, the Django backend essentially is just SQL, but Pythonized. So all of the features in Django are available in some way with SQL. So there's a few types of associations that we can do between fields. One of them, the easiest one, is a one-to-one field. So what this means is, let's say that I have a passport model and a traveler model. Each traveler can only have one passport in this world that is described on the screen. So when we're defining our fields, let me see if I can annotate this just to show what I'm talking about. Yeah, this will work. So we could have like a class traveler that takes stuff from models.model. And then we can have the traveler have like a name, for example. But now if we need to have, let's say, a class passport that also comes from models.model. Oh, there needs to be an S in there. Then we can have the passport has an owner, and this will equal models.one-to-one field traveler. So what does this mean for us? Well, all of this that this is saying is that each traveler or each passport can only have one traveler associated with it. So if we were to create like two tables, one table of travelers and one of passports, there would be like a direct link between each passport to each traveler. So does the connection between these two fields using the one-to-one field make sense? Any questions about that? Okay, perfect. So I'm actually going to step out for just a second because I have to handle something real quick. But when we get back, we're going to talk about two other types of fields. So I'll be back in 1 second. Let's get started back over here. So we just talked about how we can set up a one-to-one field, right? So each passport basically has one owner, which is links up to a traveler. So I mean, if we wanted to like draw out like a sample table, we could say that this is like, let's say this is P standing for passport. This is like your ID of the passport, and this is owner. That definitely looks like an owner. And then over here, we could create a traveler. Okay, actually, wait, that was really messy. Let me do that down here. There we go. So we can have a P and a T, and then this guy can be like your ID, and then you'll have an owner table or an owner column. And then your travelers also have distinct IDs. So if let's say passport ID number 1 is going to be linked to owner number 2, or owner is going to be linked to traveler number 2, then we can have a link going between these two like so. Then for passport ID number 2, this could be linked to like owner number 1, and then this matches up like so. So basically there's a individual relationship between a passport thingy and a traveler thingy. So I know that I've shown this like 3 different ways, and it may feel a little bit redundant, but these different methods of visualizing can often be helpful to understand exactly what's going on. So hopefully this helps you guys out a little bit as well. So let's move on to the next type of association. The next one is a foreign key, which is essentially the same thing as a many-to-one relationship. So obviously one person can only have one passport in this model. But if you're traveling, generally you might have more than one suitcase. Like some people who I will not name, who I know very well, will regularly bring 5. I don't know why, but they do. So we obviously need to incorporate something that allows us to have a many-to-one relationship. So we can do the exact same thing here as we did in the previous case. So I can create a class traveler, and I can say this is model.models. I can give it I don't really need to fill it in with anything. And I can also then create a class for suitcase. That sounds like a good class name. Say model.models. And we can give the suitcase, we can give that an owner. We can say owner is going to be models.foreign key traveler. And let's move this guy over here. So what does this mean if we go back to that table format that we just talked about before? So let me make a table here and a table here, and we'll call this one the suitcase table, and we'll say that this one is the travelers. And for the suitcases, they have an ID and an owner, and the travelers have an ID. So let's say, I have 1, 2, 3, 4, 5. Let's say I have 5 different travelers, and I have 5 different suitcases. So what the foreign key lets us do is it allows us to connect one traveler to multiple suitcases. So I could easily say, for example, that the owner, that wasn't supposed to happen. I could say, for example, that the suitcase with ID 1 is owned by the first guy, but the suitcase with ID 2 is also owned by the first guy. But the thing with number 3 is owned by guy number 4, 4 is also owned by number 1, and 5 is owned by 3. So in this way, we see that we can link up many suitcases to one traveler owner through the use of the models.foreign key field. Are there any questions about this field and how it's different from the one-to-one field on the previous slide?
Yeah, so you wouldn't do anything on the travelers field, it would be in the suitcase, or am I wrong?
Yes.
Or how would you write this?
Yeah, so you wouldn't do anything in the travelers field. You would basically only edit it, or you would only write this within the suitcase field. Because so when you create the relationship in the suitcase field, there's automatically a way to access the models that are related. So, okay, let me rephrase that. So right now we have an easy way to tell which owner or who owns which suitcase, because we built that into the suitcase class. What Django does in the background, we won't get into how to do this today, but I believe this should be shown tomorrow or over the next few days, is there is a way to basically run this backwards. So if I give you a traveler and I give you a traveler's ID, Django gives you a way to figure out which suitcases that traveler owns. So that's sort of like unwritten, but that is something that Django incorporates for you. And Christopher, this is exactly how you would keep 6 Pokemons on you.
Omar, do you write all of this inside the models py file?
Yep, this all goes inside the models.py file. I'm going to actually code something in a few minutes if you'll want to see what that actually looks like. But basically, all of these associations are within your models.py. And here's the reason why. So in addition to your suitcase just having an owner, it also probably has like a weight limit, a color, stuff inside it, etc. And those are all fields that would go inside your model. In addition to that, the owner is also something related to your model. So why wouldn't it go in the models.py field? Any other questions about this one before we move on to the many-to-many relationships? All right, I'm going to zoom nuts. Now we're going to talk about the last one, which is the many-to-many field. So this one is a little bit more complicated and messier, to be very honest. But a many-to-many field basically connects many objects together. So here, for example, we have planes and we have travelers. So each plane can have many passengers inside of it, but each passenger could also be on multiple planes. Like think about like a connecting flight. If you're going from like New York to Los Angeles and you have a connecting flight in Chicago, you're on both of those, you're on two planes. But at the same time, there are like millions of planes flying around. There are probably thousands of planes flying around the United States on a given day. And each of those has thousands of passengers. So how can we incorporate these relationships together? Well, this is where a many-to-many field comes in handy. So again, I'm going to do the exact same thing. And we'll say class. We can say traveler again. And we'll say this is models.model. And we'll leave it blank for now. Then we can also do like a plane class and say that's a models.model. And then now we can specify that our passenger is going to be a models.many-to-many field with traveler inside it. Yeah, that should work. So what does this relationship look like in practice? Again, I don't think I'm going to draw out the whole table this time just because it's pretty obvious based on the screen. But for one plane, for example, you can connect it to multiple travelers, and one traveler can also be connected to multiple planes. So it basically makes it a whole lot messier and also useful, but also just like a whole lot messier. So to recap, the three types of associations that we have one-to-one fields, which again, all of our fields are connected using the IDs. So one passport ID connects with one user ID or one traveler's ID. Then we have the foreign key, which is a many-to-one relationship. So you can connect many suitcases to one traveler, but you can't give many travelers the same suitcase. And then lastly, we have many-to-many, which is the whole mess. So you can connect a bunch of different things to another bunch of different things. You can have one plane having many passengers, and you can have one passenger being on or having tickets for many planes. So those are the three types of fields that we're going to be dealing with in our Django models. Are there any questions about the three fields before we go into some actual examples?
I think we understand the concepts. We just need to see it in code, you know?
That's fair. We're getting there. Don't worry.
One question I did have though is you just mentioned that they have to be IDs now. So we can't select individual table properties to associate. It's always just going to be a table ID or a row ID.
So that's the default way that it will get associated. So if we remember back in SQL, we have the primary keys of your tables. Well, the primary key is that's what you're going to associate each property or that's what you're going to use as the thing that distinguishes users or objects in the model from each other. Because, for example, you could have like two passengers that have the same name, the same age, the same passport number, the same, like a whole bunch of things. But the only way we know that they're two different people is because they have a different primary key or a different ID in the table. So that's why by default, SQL and Django will use the ID as the connector between the two different tables.
Okay, all right, thanks.
Any other questions? I'm pretty sure I heard another one or two voices. No? Okay, so let's go ahead and see how this works in a code example. So you guys already asked a couple of questions. We're going to skip this. So let's talk through this example here with the types of associations. So here we have a 6-piece set that has a medium charcoal gray wood finish with 4 chairs and a bench. I think that's really all we need to know. Half of this just looks like marketing jargon. So we have a couple of objects involved here. We have a dining set, which is the whole like table, chairs, stool, and all of that. We have the stool class. We have chairs, and we have the whole kitchen that contains everything. So let's start off with the kitchen. So a kitchen can have multiple dining sets, hypothetically. I mean, in my experience, most kitchens usually have one, but hypothetically, you could probably fit, multiple dining sets into one kitchen. So you can also have multiple dining sets being related to multiple kitchens, right? Let's say if, one IKEA dining set could be sold to like 100 houses or homes across the country. And similarly, each home could have 1 or 2 IKEA dining sets. So that's why we would create a many-to-many field between the dining sets and kitchens. Now, okay, let's see. I guess we should probably have gone from the top. Yeah, okay, we'll do that now. So starting off with our dining set, we're using our dining set as like our base field. So the dining set is basically going to just have like a name and a color. That's it. So it's just going to be a 6-piece set in medium charcoal gray. So what do we know our dining set has? Well, our dining set has a stool. How do we know that it has a stool? Because, well, they tell us, and bench. So how many benches are included in our dining set? 1. Can a dining set have multiple benches? No. Can a bench have multiple dining sets? No. So we know that we need to use a 1-to-1 field. Why? Because one dining set has one bench. One bench is associated with one dining set. So how do we connect these things together? Well, this is where the 1-to-1 field comes in handy. So the first thing that we do when breaking this down is we'll make in our stool, we say our stool is associated with a dining set. Our stool has a dining set. Now that dining set is a 1-to-1 field that is of type or that is of a dining set model. Okay, what are these other things? We didn't talk about those. So remember how a few slides ago, I mentioned that there was a way for us to figure out what, I think this was for the passport example. Let me right click, there we go. Oh, go back. So for this example, remember how I said that there was a way for us to figure out which traveler owned which suitcases a specific traveler owned, even though we only defined it right now as which owner or who is the owner of the suitcase. So again, flipping the arrows back around. The way that we can flip those arrows back around is by using the related name feature. So the related name basically, it doesn't exactly create, but I guess you could think of the related name as putting something in our dining set class that looks, here, let's see, class. dining set. And then that'll basically introduce a stool equals models dot 121 field stool. Let me make that bigger. So basically, that's the function of the related name up here. It basically serves to say, all right, I know that I have my stool is associated with one dining set. Let me also make sure I have a method to show that my dining set has a stool as well. So using this feature with the related name, if I give you a dining set, you can now say, give me this dining set dot stool, and you'll get the stool associated with that dining set. If I give you a stool, I can say stool dot dining underscore set, and you'll get the dining set associated with the stool. And then the last bit that's kind of important here is the on delete. So what this basically says is if I'm deleting a dining set if I'm deleting a dining set class, I also need to delete the dining set field associated with that stool, and vice versa. And those are the three components of a field. You basically have, for any field, it's the type of field, and then open parenthesis, and then say what thing it's associated with. You need to put a related name that basically says, how do I backtrace this in the other class? And then when I delete it, I want to delete the models.casting. Any questions about that example or what it's doing? I know this is a little confusing. It'll hopefully be a little bit less confusing when we actually start coding it. But if you guys have any questions now, please let me know.
Oh, don't you have a related name for your many-to-many field?
See, why am I trying to look for that? That's a good question. I think there should be a related name there. I'm not sure why it's not included in this specific case, though. But personally, what I would do there is I would include a related name of kitchens.
Hey, Umar, I'm sorry. Can you explain the cascade thing again one more time?
Sure. So the cascade thing basically will go through and delete if you're. Okay, let me think about how to explain this again, because I don't think I was very clear last time. Okay, so if you have a model that. No, that also will work. Okay, so say you have like your table of stools and your table of dining sets. If you're going to, okay, there we go. If you have a table of stools and a table of dining sets, and you delete a dining set from the table of dining sets, that will also delete the stool associated with it. Hopefully that makes sense. I know it's a little bit confusing, but it gets easy. Trust me, it gets easier once you start playing around with it.
So kind of like if it were like a sprite and like there was a table with a little stools all over it and they were just attached. If we deleted the whole table property, all 4 attached stools would disappear, essentially, because they're linked.
Yes, except remember that this is a 1-to-1 field, so you wouldn't have 4 stools associated with it, you just have 1.
Gotcha. Thanks.
But what you're thinking about would be for the chairs, and that's where the next part comes in. So this chairs one is the same thing, just with a foreign key instead, because that means, right, we can have multiple chairs in a dining set, but not multiple dining sets in the chairs. That doesn't make logical sense. So if you delete the whole dining set, then you delete all of the chairs associated with that dining set. But if you just delete a single chair, that should not delete the whole dining set. So yeah, so Don, just to reiterate, so the foreign key is one, or the better way to think about it is many to one. So 1 to 1 is just 1 to 1. Foreign key is many to 1, and then many to many is many to many. Let me clear all these annotations real quick because it's a little bit messy. So yeah, we could say like one, or we could say many chairs in a dining set. Here we have one stool for one dining set. We could say many kitchens have many dining sets. And that's at least I think that's an easier way of thinking about it.
Why don't we have a many to many field in our dining set if kitchen and dining set, or yeah, kitchen and dining set are both many to many?
Well, it's the same reason why we don't have a 1 to 1 field in dining set if stool and dining set are 1 to 1. When you define that relation for one field, Django will basically go in and also create that relationship for the other field. So that's not something you have to do. Though that's where the related names come in to that, because they're in the related name, it says, okay, what am I going to call that? New relation isn't the right word, but that's basically what it's doing.
Hey, Umar, does the many to many field, does that create an association table in our database?
I don't think so, but I'm not actually sure. Francisco, do you know?
Yeah, can you repeat the question?
When we use many to many field to create a many to many relationship, does it create an association table in our database?
Yeah, so that's one of the really cool things that happens with Django. It actually doesn't create an entire association table inside of your database, but as we know, it needs one, right? Because it needs to be able to recognize one another. Well, once our code compiles, Django builds that internally, and it holds that at the Django level, but it never passes it down to Postgres. So all Postgres is tracking are different IDs, but Django on its own is tracking all of the different IDs that could belong in this many-to-many relationship, and it's tracking that extra relational table that you're talking about. That's a little bit more in depth, and I want to make sure the rest of the class isn't getting lost there. Just know that Django is handling those relations and not Postgres, so you won't see that many-to-many relationship show up inside of your SQL database.
Cool, thank you.
So with that, would you be able to look to see where those relations are? Is there like a command or something you'd be able to put in somewhere to see where Django is holding those relations, like you would do in SQL?
Yeah, so that's going to be going into queries, and we won't be touching queries until tomorrow. But definitely once we go into queries tomorrow, we'll go over how we can see all these different relationships.
Awesome.
So ultimately, Django is just like simplifying the whole relationship and constraint process and just making everything easier.
Yes, and that's the end state, correct.
Nice.
Any
So
other questions?
oh, sorry, I was gonna ask one more question. So say you delete a kitchen set, and it's creating that field within the dining set class because it's a many to many field. Will that automatically be like cascaded?
You're referencing to the many field. I'm assuming this was a question that was meant for me. I'm sorry if I'm taking over here, Omar. But that many to many relationship, and again, we're probably going to go a little bit more into it here shortly, but it's interpreted as a set, and what it is a set of different IDs. So basically, once this kitchen is deleted, right, the dining set will still exist, but that ID that belongs to kitchen will be removed. All the other IDs that are still inside of that many to many relationship will still coexist within that dining set.
Makes sense.
Yeah. Perfect. So if we go back to the airplane example here, it's basically like saying, all right, if I deleted this airplane over here, the relationship between this airplane and this guy will get deleted, and the relationship between the airplane and this guy will get deleted. But those two dudes are still there. It's just the relationship between them is removed because the airplane in that many-to-many key is removed.
What if
That
you
makes
remove the
sense.
dude?
Sorry, say again?
What if you remove the dude?
Well, it's the same thing. If you remove, let's say if we remove this guy, then all of these arrows go away. So those arrows don't exist, that one doesn't exist, that one doesn't exist, that one doesn't exist. But these guys still exist. And these planes all still exist. So you'll still have like that relationship, and you'll still have that relationship. So even though you deleted the person, the planes still exist and the other people still exist.
So would it change anything if in that many-to-many field we put on delete cascade, or would that break this functionality? Or does it not matter?
I don't think it matters, but I'm actually not too sure. Take a look though. That is a good question.
What's the question?
Oh, we were wondering about if you put a cascade in the on delete for a many-to-many field, would that affect things at all?
Yeah, so that would cause an error, because the purpose of the many-to-many field is that things can still coexist, even if another instance or another data table entry gets erased, right? So if we think about the plane and passengers that can be on a plane, if one passenger is no longer boarding that plane, we still need that plane to exist, right? So that plane needs to exist for all the other passengers that are going to be getting on it. So we can't use an on delete cascade in that specific scenario. There's a lot of questions about many-to-many field, and the example that we're about to see here in the Pokemon example that we're doing will go strictly over the many-to-many field because we expected this to be a friction point. So let's we're getting stuck a lot on this slideshow. Let's move forward and let's take a look at some code so that things can make a little bit more sense.
Great, sounds good. Thank you, Francisco. So yeah, let's go ahead and jump back over into VS Code. So as we just talked about, we now need to create, we're going to create a many-to-many relationship between our Pokemons and our moves. Why are we creating a many-to-many relationship between them? Well, we can have one Pokemon can have a bunch of different moves, but also one move can be associated with a bunch of different Pokemons. So let me close out of some of these additional tabs and let's open up our Pokemon app models. So we're going to keep everything else the same. So I'm still going to keep all of my original fields. But in addition to those original fields, I'm also going to now add in my relations, or in this case, my many-to-many field. So what I would say is these are like normal fields, and then after that, I will put in my relations. So we want to create a many-to-many field between our Pokemons and our moves. So what we could do is we can say moves, which is going to be the name of all of the moves associated with our Pokemon, are equal to models dot, and now we can create a many-to-many field, which as we see here, oh, it was just showing that. Here, let me move this many-to-many field. And again, it says this provides a many-to-many relation using an intermediary model, which we're not going to talk about, that connects between our Pokemon and our moves. So we can create a many-to-many field. What class are we going to link our moves to? We're going to link this to move. We can't access move. Why? Well, probably should have imported move a little bit earlier. So we can pop this into our imports. So we can say from, let's say move app dot models, and I'm going to import my move class slash object. So I can now create my many-to-many field with my move, and can also create a default value for this. And we can just say that the default value is that everything is associated with the move with ID 1. We can say default, so create many-to-many relationship between Pokemons and moves, and then set, oh, am I not typing? Oh, there we go. Set default move to first move in moves 2. So we move this back over to the side. So we now have our many-to-many field, but let's also create a clean method for this, just like we did in our move app. So this one just double checked that our current PowerPoints were not bigger than the maximum. Well, we also only want to give a Pokemon, I think it was 4 moves. So let's do that. So let's write down a clean function, and let's put this here so we can say ensure Pokemon has 4 moves at most. So we can define a clean function in self, and we can say if self.moves. And now we have so what is our moves? So moves is going to be a many-to-many field that is a class. So what is that going to return to us? Well, it's going to return a many-to-many related manager. If we mouse over this, that is not a list. That is not a dictionary. That is a special many-to-many field data type / intermediary that Django has created. So how do we figure out what things are inside it? Well, for that, we can use a dump. So we can add things together, we can aggregate them, we can get counts. And for us, what we're going to do is we're going to get the number of things inside of our moves table. So we want to check if the self moves is greater than 4. And if there are more than 4 moves inside, we can raise a validation error. Oh, I forgot to import that. Let's see, where was that import? Yeah, Django core exceptions. We'll put that in down here. So now we're going to raise a validation error saying a Pokemon can have at most 4 moves. And what this does, it says how many items are associated with us through moves. And then we can raise a validation error that says a Pokemon can have at most 4 moves. So this is how we can set up a many-to-many relationship within our models. So again, we're keeping our model the same, but we're just adding in a new field for our relations. I'm setting up a many-to-many relationship between the Pokemon and my moves. And then I'm just doing a clean at the end that says, when I clean stuff, I need to double check that we only have at most 4 moves associated with our Pokemon. Any questions about what I just did? And let me catch up on the chat real quick as well. Yeah, so as Francisco mentioned, this is based off of the SRP principle. We want to have each app handle 1 model because that'll just help keep things a little bit more organized. And that's basically the only reason why. It helps to keep things more organized and simpler for us to deal with. And also it is good practice to just have that in general across a lot of other languages too. So if you think about it in the same way as in Python, would you necessarily have one file that has all of your classes and functions and data imports and exports? You'd probably have one file for your data imports, one file that deals with all the things for one class, one file for all the things that dealt with another, and so on. So it's essentially the exact same principle of deconstruction. Yep, I had my headphone just fall out. Okay, well, that should go back in. All right, any other questions about what we just did, or do you guys want to see this in practice? All right, and it looks like there aren't any questions just yet. So let's go ahead and run our make migrations. So we'll make migrations for Pokemon app for starters. We just did that, and we'll make our migrations also just in case for the Move app. No changes detected. Great, so now I'm going to migrate my changes. Yep, and it says that it's been applied, so perfect. So now we can go ahead and enter into our PSQL if we want to. We can say Pokedex database, and see if we look at the commands that we ran. We see here in move app that move that looks exactly the same. We've just got our psychic with 70 accuracy and all the other stuff. And if we look inside of our Pokemon app and we check our Pokemon table, we see that that table also looks exactly the same. So we don't have any proof inside of Postgres that we have a many-to-many relationship between things right now. It's really necessary to make migrations. Robert, I believe it is, because if we go up here, where'd it go? Yeah, it adds the field moves to Pokemon. So because we added a field, you should make your migrations before migrating them over. And also in general, it's just good practice whenever you migrate to first make migrations, just in case. Okay, so we can't see our many-to-many relationship in Postgres right now. So how do we know if this thing actually happened? Well, now we can go into our PSQ, into our Python shell. So if we go to Python manage.py shell, we are now in our shell. So we can go, let's see, where are we? So we could say let's not import move app right now. Let's go to our Pokemon app and we can import Pokemon. Oh, that's why. From Pokemon app dot models import Pokemon. There we go. And we might as well also import our move. And let's just double check that we still have Pokemon inside of here. So we can say, let's make a variable, we'll call Pokemon1. And we can say that this is going to be from our Pokemon objects. So if we go up to our table here, remember that the select star from Pokemon app Pokemon gives us all of the instances of the Pokemon class. So we've got two, we've got one with ID 1 and one with ID 2. And what I want to do is we want to go to all of the list of all the objects in my Pokemon class, and I want to get out the first Pokemon. So I'm going to get out the first Pokemon, but how do I know which one's the first Pokemon? And this is where the ID comes in handy. So remember, the ID is our primary key. It's our unique field. So if I specify that I want to get the specific Pokemon whose ID is equal to 1, there's only one Pokemon whose ID is equal to 1. And now what I can do is I can print out my Pokemon 1 just to make sure that I get something. Ta-da! We get Pikachu, which is perfect because that is indeed the first Pokemon that is in our table. Now, remember that the entire point of us going through this exercise was to create a many-to-many field that connected our Pokemon database to our moves database. So I want to make sure that my Pokemon has a move associated with it. Because remember, when we just went into Postgres and PSQL, I don't see any moves there, which is trouble. So if we now try to find out the moves associated with our Pokemon, let's create a variable in Python called moves. And we'll say this is equal to Pokemon1, which is our first Pokemon. And now if we go back up here to relations, remember that the name of the many-to-many field relation is moves. So we can type Pokemon1.moves. And now if we type .all, that tells us all of the things inside of our many-to-many field, or all the moves that are associated with our Pokemon 1. So if we print out moves, we now get a query set that is blank. That also should not be happening. Hang on, let me double check that I did this right. Import. Okay, well, in any case, I'll debug that a little bit later, but when you guys run this, hopefully your query set should not be blank, and it should show you that there is a Pokemon, or that there is a move associated with your Pokemon. That should be, oh, go ahead.
I'm so sorry. Where did you add the move to Pikachu?
Didn't you set the default to 1 in the class Pokemon?
Yeah, over here.
In the many-to-many, yeah.
Okay, I think
you know what? Actually, that. Oh, go ahead.
Oh, I'm so sorry. I think you missed the default argument there.
Oh, thank you. Yes, that would do it. Okay, here, thank you for that. Let me exit this, exit, and let me rerun my migrations just in case. Oh,
Okay, it seems like it didn't like that.
yeah, that's a little bit weird.
Mine had the default and still came up empty.
Interesting.
Yeah, mine as well.
How is it linked to the moves model?
So that would be through this line over here. So you're linking it by saying that you have a relation called moves, which is going to be a many-to-many field that connects your Pokemon model with your move model.
Nice. All right. Yeah, could you remove that default argument real quick? And then we could just go into the Python shell and add it manually.
Sure.
Yeah,
let me just
check the line 41.
Sorry, you said line 41, this one?
Yeah, the default equal in the end.
Yeah, it looks like, oh, that would, why did that show up there? Okay, interesting. Here, let me add that default. Let's see if it'll work now. Okay, well, it looks like that worked. So let me, wrong app. This is supposed to be Pokemon app. Okay, and we'll just run the migrations real quick. And we'll go back into the shell. And let me just do all of that again. So we'll import Pokemon, import move, and we'll create our Pokemon 1. We can print it and make sure that it's still Pikachu. That's good. And we can double check all of the moves, and I don't get any errors when I run that. And now if I print moves, it still gets a blank query set.
Could you do Pokemon1.moves.add and then in parentheses place 1?
One like this?
Mm-hmm.
Okay. Let's see if that'll do it. Thank you. Okay. That would explain it. I think I needed to think I would have needed to add the add and remove functions for it.
Isn't it supposed to
But,
already
yeah.
happen as default?
I think the reason that this happened, actually, if we go up to our relations, is because I already created the Pokemon in question previously. So the Pokemon in question that I created is this guy, which is in my fixtures. So as you'll see, it doesn't have any field for the new relation. So if we'll go back to where's the code? To the code over here, the only time that that field will get added is when I create a new Pokemon. So because I didn't create a new Pokemon here, it didn't automatically set it to be the default.
Can we create one so we can see that happen?
Yeah, sure, let's do that. So we could say like Pokemon 3 is going to be I want to do this. We could say this is a Pokemon. What are the inputs I need? Where did that go? Pokemon app. We'll put in a name and we'll just say name equals sample Pokemon. We don't need levels and we don't need everything else already has things created in it. Perfect. So we'll double check that I can print Pokemon 3 and make sure that it was created without any problems. And now I can double check, let's say moves. So actually we can just print out our Pokemon 3 dot moves dot all. Needs to have a value. Oh, sorry, I forgot to save it. That's why. So Pokemon 3 dot save. Okay, now that should work. Interesting. It looks like it still didn't add the default. So, I guess here we'd also have to just add it using the add feature, unfortunately. But yeah. Francisco, any additional insights on this?
Yeah.
Adding it by default without the need to run add.
Yeah, I'm trying to figure out where exactly it is that we might have gotten off course. I can see the move app here. I'm just moving down to where we make the connection.
Anyone else who's following along, are you guys also getting the same blank query set?
Yeah,
when
I
you
am.
run this? Okay.
Yeah, I'm getting the same blank query set.
Yeah, that should have created the default value.
Does it matter if you establish your many-to-many field within your Pokemon model or your move model?
Not really, because it still creates a many-to-many field between the two of them. So if we were to create it in the Pokemon models, then we'd say moves equals like this. But if you wanted to do this inside of move, hypothetically, then what I would say is something like Pokemons equals models dot many-to-many field. I'd put in Pokemon after importing it. And then I would just say that the default Pokemon that has all the moves is the first Pokemon.
And
So it'll do the same thing.
Does it matter you don't have a relation name?
The related name, yeah, that we don't need to have that for yeah, it's an optional parameter.
Within your models, do you have to import the Pokemon app as well? Or no? Inside your move? If it's a many-to-many relationship?
Don't believe so.
Inside of the Pokemon model, could you go ahead and remove the square brackets and then just try to do it with just the one on its own? And I want to see what its behavior is going to be. I wonder if this will show in it.
Let's see. So run our make migrations. Okay, altered the field, and let's migrate that. Okay, and now we'll go back into the shell, and we'll just do the same thing. So we'll say, we'll go back up. Oh, I have to import everything. So we'll go there, then we'll import that guy, and we'll just double check our Pokemon 1, and then we'll print out Pokemon 1.
I think
Moves
Pokemon
on.
1 already has the relationship from when we added it earlier.
Oh, that's true, actually.
We'll have to create a brand new.
Okay, well, we'll just do the same thing that I did last time. So we'll say we're creating this new Pokemon. We'll just make sure that this guy is going to get saved. Okay, here, let me make a new one. Pokemon 2.
I just tried this on the existing Pokemon and it worked.
It did?
It did for me.
Okay, that's good to hear. Let me just make sure that it works for me too. Otherwise, we may have other problems. Okay, so that saves, and now we can print out Pokemon dot moves dot all. Okay, it doesn't look like it is for me. But Calvin, in the meantime, do you maybe want to share your screen just so folks can see what a working example actually looks like?
Yeah. So I did what Francisco said, and where is it? I'm lost. Oh, I set the default to 1 without the brackets. And then I imported all this stuff. I guess I don't think I needed to, but I set Pokemon 1 equal to Pokemon objects dot get ID equals 1, which is Pikachu. And then I printed the moves dot all, and it gives me this, which is my first move that I made.
Okay.
I'm not sure what I did differently from you because I'm pretty sure I did everything exactly the same.
So did you open the shell beforehand or like before just now? And did you also follow along with the dot add that I ran?
No, I didn't even do that.
Huh. Interesting. Okay. Well, that's something that I'll debug that after I let you guys work in your teams today. But
okay,
I'm glad that you were at least able to get it working. Did anyone else manage to get it working as well, or is it just Kelvin?
Yeah, it just worked for me too.
Okay, interesting. So, let's see. I'm gonna pause the recording for now.